So a big welcome to everyone again today. We've got a very interesting topic with Dr. Daniel and Dr. Sam, scientific methods for critical thinking. So scientific methods are something that you'll hear all around you. There's science as a subject. There are also scientific approaches that we're using, and it's very central to the idea of critical thinking. Are you being scientific? So we're going to also consider, as Christians, what does Christian faith mean in terms of science, how it fits well together, and how Christians over many centuries have been keen on science. We're going to look at a range of sciences, from astronomy to geology, chemistry to physics and biology and living things, and also to the human sciences and the arts. And we're going to look at how certain methods like observation and measurement are used in each of these. We'll look at the possibility of using experiments, but I imagine that if you're wanting to study life on Mars, then experiments could be more challenging. Let's begin with a Bible reading from Psalm 19, which is a reminder that in ancient times, in Rome, in Greece, in the Hebrew world, they also had an awareness of the importance of understanding the natural world around them and also ways of interacting with it. Psalm 19. The heavens declare the glory of God, and the skies proclaim the work of his hands. And day after day, they pour forth speech and reveal knowledge. They have no speech with words. No sound can be heard from them. Yet their voice goes out in all the earth. And this is partly what scientists do today. They look to the natural world around and they're aware of the revelation that is there. And Christians who are scientists would say this is a revelation of God's world and therefore of the architect and maker who is God. The law of the Lord is perfect, refreshing the soul. The statutes of the Lord are trustworthy, making wise the simple. And many Christians who've been scientists, like Isaac Newton and others, saw that there were laws that were in the universe, and it's part of our responsibility to identify and describe these laws in the universe. As an opening prayer, Lord, we know that you are our creator and have chosen to reveal to mankind, partly through the study of the sciences, limited insights into the processes of the world you've created. And we know that due to our sinful natures, mankind's taken this information revealed to us. Sometimes we've had intellectual pride rather than glorifying God. And so we humble ourselves before you and ask that you direct our research to reveal information that may be used to glorify you as creator, that may be used for good for one another. We specifically pray that this information will influence us who are being trained in teaching and in the sciences and scientific method to realize and accept your written word to us, your truths to us, and accept the truths that you reveal through the world around us. We have a number of resources that will be put up onto Moodle today, including discussion of scientific methods. What are the scientific methods? How do we use them? And then there'll be more scholarly analysis of scientific method, like the Stanford Encyclopedia of Philosophy article by Brian Hepburn and Anderson Hayne. And we ask you to read 5 minutes or more from that. And if you're finding a lot of interest in that, you can read a lot more there on what scholars have written about the history of science and the methods used in science. And we also put up those who've pointed out that science isn't always about nice, neat methods. There can be aha moments. There can be other ways in which these discoveries are made. So there's lots of resources. If you want to pause the video, make a note of those, do some searching on those, you'll find that very helpful. In New Zealand, in a Maori context, you've also got the New Zealand Council of Educational Research has a list of competencies in science that you may find valuable from both a Western science point of view and also from a Maori native people view in New Zealand. Other resources include Peter Harrison's Rise of Western Science and Christianity on ABC, and Peter Harrison's written much on the history of science that points out that Christians have played an important role there. So there's a number of outcomes in today's lesson. We want to understand science and its methods. We want to look at questions, observations, hypothesis testing, how useful this is. And we also want to look at the history of science, which goes back to Plato and Aristotle, and then through the 1200s and the 1400s to the 1800s, when new methods are added. And then we want to conclude by thinking further about Christian faith and science. Particularly, we want to warn against pseudoscience, where people make authoritarian claims that are not tested, that are vague and disconnected from the real world, that are wishful thinking, that have flawed methods that can't be repeated, that are closed off to other views, that are dogmatic and unyielding. And whether it be business or whether it be any subject, economics, whether it be Christian studies, these sort of approaches aren't going to lead you closer to the truth. As Carl Wieman once said, Nobel Prize winning scientist, the purpose of science education isn't just to train a tiny fraction of the population who will become next generation of scientists. It is to make all people more literate to address the global challenges that humanity faces. And I was talking to Daniel before about how every day we have to make choices that relate to science. I eat breakfast, and on the side of the breakfast cereal, there's a list of nutrients, and I can make a choice whether I'm going to eat that or whether I'll go straight for the ice cream in the freezer. And so science is influencing us all the time. I drive the car. There are dials there that are telling me what's happening. I'm teaching you as students, and there are scientific studies on how students learn. There are scientific studies on neuroscience. So all around us, there are decisions about science. So Daniel, why is science important to us? Can we just be a teacher of preschool children, or can we just be a teacher of the arts or physical education? Why do we need to know something about science, Daniel?
Yeah, I think the quote we've got from Wyman is quite appropriate in considering that for this week, because you mentioned before, Sam, the scientific studies that have been done on how students best learn, and certainly the studies that have been done. We can think of as well the amount of studies that we've read on particular theories of teaching or learning. And so ultimately, as a discipline, science very much gives us a really brilliant framework from which we can grow and develop as teachers. And certainly much of the psychology and the social science that we encounter in studying education is derivative from the methods of science itself, gathering data, making a hypothesis, analyzing what the data says. And so science ultimately is something that we'll do in the classroom every day, because we need to understand, first of all, okay, what has my past experience, or if you've got a class you've taught before, what has my past experience with this class taught me about how these students best learn, how I know they will respond to different stimuli, how I know they will respond to different activities as well. If I haven't had this class before, what type of observation, what type of data analysis do I need to do myself in order to figure out how best to teach this class? And you'll be doing that kind of analysis and observation every lesson, because you're trying to figure out how your students are going, how they're interacting with the content, whether they're understanding the content. And so if science is a discipline of analysis and a search for knowledge and information, then regardless of whether we're science teachers, regardless of whether we're primary school teachers who have to teach a bit of science, every discipline in essence involves the scientific method.
As so well explained, is that as teachers, we have to understand that there are certain approaches to science, like observing, gathering data, information, that have been tested and shown to be valuable and true over many centuries. And in this sense, the world is constantly advancing, though sometimes we go around in circles and try older ideas, but we are testing things. all the time, whether it be in education or whether it be in other areas of science. Certainly there will be some students in our class who are interested in physics and chemistry, geology, astronomy, the very subjects of science. But we, as you said, Daniel, as educators also need to be aware that there is a science of education. There are approaches to observing how students are performing, what influences them as they go along. So science is both a series of methods like questioning and observing, taking data, and also a series of topics which looks at the natural world, which can include students, thinking, the brain, the body, all of those things that are around us. We can find some insights into the nature of science by again looking at history. And history reminds us that the study of science is not something that just happened in the last few hundred years. You'll get books that'll say the study of science began with Galileo, or the study of science began 200 or 300 years ago. But science has been around for thousands of years. And back in the time of Aristotle, he wrote about the ways of analyzing information, gathering information, using information. And Aristotle, in his book, and you can download a copy of it on the analytics, said all instruction given or received by way of argument, so we put forward an argument, proceeds from pre-existing knowledge. That is, we've got language from our culture, we've got knowledge from others, and an admission of facts, that some of which have got to be assumed. And then we've got to comprehend and find the meaning of them. There is knowing that's accidental, and then there is scientific knowledge, where we observe and where we make note, we interact with others, we try and prove that knowledge. Some hold that owing to the necessity of primary premises, that is, we've got to have language and ideas to start with, there can be no scientific knowledge. It is just cultural. And in some ways, this makes Aristotle a postmodernist. 2022 back there in 300 BC, saying that there's no absolute knowledge, it's all part of culture. Others think there is scientific knowledge and that truths can be demonstrated, and so we could carry out some demonstration to show what is. This makes Aristotle a scientist back 300 BC. And so it is our doctrine that not all knowledge can be demonstrated. So what about the unseen things, the thoughts that people might have, or political decisions? Can we fully demonstrate what's going to happen in the future, or what happened a long time in the past? There are advocates of circular demonstration, where we go around in circles and try and prove something using what's already been shown. That's an error. And we can fall into error because our conclusions are based on just one case. I thought this, I saw that. These two are mistakes. And Aristotle goes on to talk about some of the strengths and the limitations of observations and the approaches that we take, as does Plato and other of the ancient Greeks. So we point this out, that science is not just something new. It's been around for a long, long time, and it's important in the lives of everyone. We got the rural and the city divide, and some people say, oh, the science people are in the city, and you got farmers out in the rural. They too are looking and observing, measuring. They too are dependent on scientific knowledge. So it's all around us in different cultures. One of the things you'll do in assignment 2 and 3 is think about how different cultures may look at science in different ways. And so Asian culture may see the role of the whole community a lot more, and it might be more individualistic in a Western culture, but they're still doing science. Some cultures may see the value of the natural world a lot more in native cultures, but they're still thinking about what are the reasons we believe those things that are happening. So we need to be careful that we value every student and their perspective on science, and not just some science. History reminds us that even Islamic scholars, particularly in the 1100s, the rediscovery of Aristotle through the Islamic writings contributed to maths and science and our understanding of scientific cultures. And then Christians over the centuries have contributed to science. Particularly, I'm impressed by the Franciscan friar Roger Bacon in 1214 to 1284, who developed very detailed inductive reasoning methods that are still used in scientific study today. So Roger Bacon argued that accurate experimental knowledge of nature would be of great value in confirming the Christian faith. And also, he said that mastering the languages of Greek and Hebrew and Arabic, they're important in understanding the Bible and theology. And he encouraged careful study of language in order to better understand theology. But they're also important for understanding anatomy and parts of the body and the way the eye works and health. And so he was a leading thinker of his time. And this reminds us that Christians aren't against science through history, but Christians have often contributed in major ways because their faith in God and a universe that can be understood, their faith in care and humility, and faith in telling the truth, all of these contribute to scientific method. Daniel, we sometimes hear about a conflict theory that science and Christian belief or religion conflict with one another, and yet others are saying Christianity and science, really, they're about pursuit of the truth. What's your answers to say, hey, science gives us knowledge, but don't know about religion, etc. Do you see any truth in conflict, or how do we work those through, Daniel? That sort of statement.
I think it's particularly tricky in recent years for the simple reason that the notion of science versus Christianity is something that has been perpetuated by leading voices and leading thinkers in both fields, rightly or wrongly. And I think in particular, you just have to look at the rise in the kind of seminars or big kind of, you'll have leading scientists like, a Neil deGrasse Tyson or a Richard Dawkins who sell out these big exhibition centers. And the reality is that the notion of science versus religion is something that sells. It's something that is a juicy topic because ultimately it's framed often in such a way that it seems to be all encompassing, right? That every human being can be categorized either under one of these or some combination of these two spheres. And so that's the reality, is that this particular debate is something that sells. It's something that a lot of op-ed and a lot of op-ed space and opinion articles will be dedicated to. But I think the reality, as we've talked about already, Sam, is that one can inform the other. So, if we think about Bacon, for example, his desire to learn more about the natural world was born out of his Christian faith, and in understanding that the more we learn about the natural world, the more we can learn about God. So certainly his faith is informing his contribution to science, but it can work the other way as well, in terms of when we make a scientific discovery, that can shed light on how we understand how God works in the world, or has worked in the world, or the wider universe. We talked about, for example, in an earlier lecture, the Big Bang Theory, and thinking about the father of the Big Bang being a Catholic priest, and the notion that particular theory shed light on an understanding of how God might have created the universe. So the reality is that whilst the common discourse we see is science versus religion, one can certainly inform the other. And I want to suggest as well that they are not binary opposites. There are plenty of high achieving scientists in their field who are Christian. And certainly I would suggest that this notion of, science is, science may provide, what was it, Sam? Science provides truth, but religion provides meaning, or something. What was that? The
something like that. Yeah.
And that's something that's often said, and I think people, particularly atheists, will come back and say, well, science gives me meaning as well. And I think that's a symptom of this science versus religion. They have to, it's been made into a binary in contemporary discourse, and it doesn't have to be. God, we've seen God in nature, we've seen God reflected in science, and we've seen countless examples of scientists use their faith to contribute to scientific understanding. And that's something that we ourselves can do. We don't know, even as Christians, we don't know everything about the Christian religion. Scientists don't know everything about the natural world or the universe. So we have to, first and foremost, I think, be grounded in humility and recognize that there is not a single being on the earth who knows everything there is to know about religion, who knows everything there is to know about God, or everything there is to know about the world and the universe. That, no one has all the answers. And certainly these two spheres can work together in harmony.
Just as another example of that, we see you could put into Google Scholar science and prayer, and you could see how people have studied prayer in hospitals and found that prayer can be very helpful because it builds that sense of expectation and anticipation. Certainly there can be prayer which is not so good if it takes the place of medical treatment, but the problem is not the prayer. The problem is what's left out that is needed. And so the scientific study of aspects of our faith can be very helpful. It's part of the world that God has given us. And in the same way, Christianity can help us to understand that there is a reliable world out there, that there is a world to be studied, to be interacted with. And so the two together contribute very well one to another, as you've said, Daniel. Great points there. So you can find out more about Roger Bacon at either Internet Encyclopedia of Philosophy or the Stanford Encyclopedia there. You can find out more about others through the centuries who contributed, many of whom have been Christians. And so when we read about Roger Bacon and his development of science in the those earlier times, and then we move on to Francis Bacon and his development of our understanding of nature in 1560 through to 1626. Again, we've got a Christian who is thinking through what does his understanding of God and Christianity mean. So in Francis Bacon's writing in 1620, he was cautious and critical of Aristotle's idea, leap into universal ideas too quickly. We need more careful study. As a Christian, he was concerned with sin, that is pride, that is wanting to please one another, can cause us to not consider all that is there. Galileo, in his writing, also writes about the need to honor God and recognize God has made planets to move in certain motion. And so he too is writing from his Christian beliefs, as is Isaac Newton and many others. William Whewell, who gives us concepts relating to science, says the contemplation of the material universe exhibits God to us as the author of the laws of nature. And so science is about understanding these laws that have put in place. We need to understand God's laws in the Bible. We need to understand God's laws in the natural world. And so medicine and engineering depend on an understanding of the laws that are in the natural world around us. Isaac Newton, historians of science tell us, wrote and thought a lot more about Christian ideals as much as he did about scientific ideals. But one of the things that he did was he introduced new concepts in some ways, like gravity, though at the same time he was careful to say they're not new concepts, they are concepts that are always there. One of the things that Karl Popper did was he said that science should test things to see whether they are false and true. And we can talk about religion and prayer and faith, and we learn. You pray about things, and I remember praying about a toothache once, and I thought, God, take this toothache away. And one of my students in class said, you're a member of Griffith University, aren't you? And she said, I too am a dental nurse, and we can get you in for a free treatment for that there. And God didn't miraculously take that away, but there was a person telling me what could be done, providing a resource. So God can provide answers, and we can learn through observation. We can learn through asking questions, whether it be the natural world around us or whether it be the inner world of the nature of people or the nature of spirituality. Thomas Kuhn, who's famous for writing about the structure of scientific revolution, said science too can have sudden changes. That is, we can follow a particular understanding of science, such as the Earth, the sun going around the Earth, and then there can be a change as we realize the information needs to be carefully looked at. The Earth goes around the sun. And so he called these scientific revolutions. But I think sometimes bigger revolutions can be revolutions in medicine, where they believed in humours, that is, there were gases about, but then they discovered microbes, and using microscopes to look at these microscopes and then carrying out tests, they could work out what this new paradigm is, this new way of looking at things. And religion too tells us, Jesus said, sometimes you need to repent, you need to change your mind, you need a change of thinking. So humility and change of mind are not just peculiar to science, they're needed in politics, in economics, in every aspect of life. We sometimes need these paradigm shifts where we're open to new paradigms. Atheists would say that Christians need a paradigm shift, but we would say atheists, you could be open to a paradigm shift. We all need to be open to what's the evidence around us and how we look at that. Louis Pasteur, when he discovered vaccination, there's a paradigm shift. Lister, when he discovered antiseptics, there's a paradigm shift. So we have to be open to change. And sometimes science is not just a simple method. Sometimes science is being open to big changes. Daniel, these methods, what is meant by the scientific method? What are some of the steps that are used in the scientific method, Daniel?
Yeah, these might look very familiar to those of you who either did science in stage 6 or potentially can remember any science that you did in junior school. And so we talk about the scientific method as basically a plan, for lack of a better term, a plan or a blueprint for finding out information or trying to discover something or trying to test a particular idea or concept you might have. So if we take, for example, the classic example of Isaac Newton and his discovery of gravity and the theory of gravity as well. If we take that example and apply it here, his question started when he was sitting beneath an apple tree and an apple fell on his head. And he thought, why on earth did the apple fall on my head rather than just kind of going why did it fall straight down? Why did it not float up or go somewhere else? So then he says, okay, well, I really want to figure out why that apple fell straight down, goes and observes and gathers info. Do all objects fall like that? You know, if they're not tethered to something, do they maybe fall at different speeds or something like that? And then you think, all right, based on kind of what I've observed, I can I can put together a hypothesis, which is a fancy way of saying a theory that you are about to test. This an idea that you've put together and say, okay, this is what I think is the case. I'm then going to go and test it. So you go and you plan your experiments, you figure out different, we talk about control samples, which is saying how can you make sure that your experiment isn't influenced by a number of variables or control factors. So we have the great example there of the placebo pill. So, when medical companies are testing new medicines, you might be familiar with the fact that they will test the medicine with one group and then another group will get what's called a placebo, which is a pill that doesn't do anything. And that's a way of testing whether the medicine actually works. You might have heard of something called the placebo effect. This idea of because our brain thinks that something is happening, our body kind of responds accordingly. So, I might be sick, I might have a really bad sore throat, and Sam might give me some medicine and say, Daniel, this sore throat medicine is the best on the market, it's top of the range, you will be shipshape in no time. And I take that, but really it's just like Tic Tacs. But because my brain has thought that I've taken this excellent medicine, my body kind of responds in such a way. So, So, in testing that hypothesis, you're putting structures in place to ensure that the experiment is as rigid and as controlled as possible. You process the data, say, okay, what was I able to get here? Did the objects all fall at different speeds? Do they, the moment an apple and an orange detach from a branch, do they hit the ground at the same time? And then you go into evaluating what does all the data I gather tell me about what's happened? And then you communicate your findings to the rest of the community. And certainly, we have other modern things like the literature review and the peer review of the results. Now, I don't know how much of a literature review Isaac Newton was able to do on the theory of gravity. In truth, maybe not a whole lot. But for those of you, as I said, for those of you who've done science in stage 6, who can remember science in 7 to 10, you would have had to have followed this method and likely come up with your own experiments, particularly for some of the major projects or major assessments in science.
So good. And what a great summary of these different methods that we have. And so just very briefly going through those again, often the success begins with asking the right questions. And often the right questions come from a literature review that tells us, hey, this is the sort of thing that could be happening. And then there are predictions. And so we got a hypothesis, we put forward ideas, and then we test it, carry out experiments, as you said, with the placebo, Daniel. We've got controls, and then we process the information, and then we communicate our information to others. So it begins with a literature review that considers what other scholars have said, and we acknowledge that. And so we say scholars have gone before us, they identified this as a factor, and then it concludes with a peer review where we say to the scholars, we are open to your viewpoints. What are your viewpoints? And so there are schools of thinking. And so even today in education, there'll be schools of thinking where you get all the peers who agree with you around, and then you try and be open to others who have different opinions. And so it's good to compare the views of different schools of thinking as well. And then remember, there are paradigm shifts where suddenly one school will have a big change of its ideas for others. Now, there's lots of practical activities that you could do in a classroom. One of the fun ones that I've done recently is the making of bread. And then you can ask the children, what happens if we vary the ingredients? What happens if we make a control bread with no yeast in it? What happens if we make a control bread with no salt in it? And so we can think about what are the different elements doing in the bread, the temperature we cook at it. And so we try and control all the different factors. And then if we record what happens, then we can learn from these records. We could do a literature review and find out what's the other information. We can find about yeast being a microscopic living organism. We can find out about temperatures in which the yeast thrives. We can find out what gives a loaf of bread a crunchy crust. So all of these things are partly understood through literature review, through peer review, interacting with us, but also through experiment when we observe. And in the classroom, we too have our students in front of us, and we can be asking questions. What do I think? In the staff room, we'll be talking about what's the methods that we are using. And I hope you continue to do reading during your studies and in the years that follow, so that you are up to date with the latest theory, ideas, experiments about how students learn in your particular areas. So a lot of people have listed these stages of scientific method, beginning with questions and problems, experiments, conclusions, as a series of steps that we can take on the way through. And so I encourage you to think about these different steps that are there, such as the variables, independent variables, and dependent variables that depend on other variables, control groups as well, and trials. So there's a lot that we can do. Qualitative data data is different to quantitative data. Quantitative, where we measure with numbers. Qualitative, I think, is also very valuable, where we ask questions and get people to talk about, how did you feel about this? What did you think about this? This can all be part of science. Now, science education too learns through careful study, and people have often found that inquiry-based and discovery-based science education is a great way to learn, because the students feel more involved, they raise questions, you interact with them and their questions. But at the same time, if they've not done some literature review, then they're going to miss out on finding out what others have said as well. So I think we need to balance inquiry-based, discovery-based education with ways of gathering information, tools for gathering information. You can find a lot about science in the Australian curriculum. And you could even, in one of your assignments, talk about subjects that you might be teaching in, whether it be history or English, or whether it be science. And you could think about different ways in which different cultures look at science and how they study science. The scientific method is also particularly valuable in learning. And so we can look at different theories of learning. Brunner, Piaget, Vygotsky, they have put forward different theories based on their observations, based on what they have learned. So scientifically, they're looking at how individuals learn and develop. And I think you too will be asking this question. I know I'm constantly asking with students, how is that student learning? Because one of the things I discover is if I tell students too much, then they're not getting into it and discovering it for themselves. So I want to encourage them to be thinking about what they're learning. Brunner and others said that individuals learn and develop when they use their mind. So if I'm just feeding them information, then they're not really going to develop ideas as much as I give them an opportunity to discover and explore and to handle different objects. Secondly, they said that the more cognitive processes used in this discovery, so if they're using their hands and they're dialoguing and they've got other ways of interacting with the questions, then the intellectual thrill and the satisfaction and reward is going to give better results. Thirdly, the person who learns by doing is going to better than the person who is just told. And then fourthly, if I can encourage them to get involved and excited about discoveries, then that'll strengthen memory retention. So Daniel, how does science help us understand what we do as teachers when we're teaching, when we're in the classroom? How do these methods of observing, methods of gathering data, methods of questioning, methods of being humble and trying new ways, how does all of this help us as teachers in the classroom?
Yeah, we hinted at this before, didn't we, in terms of, observing our students and thinking about how do they react to different stimuli, whether it be, a particular resource or activity, but also thinking about how do my students best learn. But, in addition to that, obviously, we have different ideas of not just how students or children learn, but also how they develop. And so this goes back to what we were saying in terms of thinking about different theories of learning and education. And so if we take, for example, the classic work of Piaget and developmental stages, that is something that is born out of, obviously, observation and gathering of data and analysis, but it means that we can use this as teachers to best understand our own students. We know, for example, for a primary school teacher, and we're teaching a particular year group, we know that according to Piaget's theory, the students in our class will be in a particular developmental stage when we take them. So we will therefore know, all right, if they're at this developmental stage, there are certain things that they are discovering right now. There are certain things that they are able to do, certain things that they are learning to do, certain things that they haven't quite developed yet. This links obviously with someone like Vygotsky in the zone of proximal development in terms of thinking about what is based on the stage that, or the developmental period that my students are at, what are some of the things that they might be able to achieve right now that pushes them to discover and to use their own minds a little bit without pushing them too far? And so like I said, we hinted at this a little bit beforehand. And so right now we're kind of fleshing this out a little bit more in really, I think, demonstrating as much as we can with the time we have today, the extent to which scientific studies not only inform the education process, but will directly inform our own teaching and thinking about, what does the research tell me about how I can teach my students today? What does the research or the scientific studies tell me about how my students will be able to learn this or incorporate this or interact with each other or whatever else?
Yeah, so these scientific studies can be cited and quoted in your assignment 2 and 3 as you think about even already, how is your thinking about education changed? It's worth putting in a few sentences that describe the aha moments when you realize it's not about me showing the students how much I know as a teacher. It's about me equipping the student to discover how much they can know as the student. So it's centered on the student, which can be different to the way we thought about things. It involves skills in constructing concepts that they can understand and work with. How can I make that understandable? Certainly using all the senses. So if I'm doing maths, then I will use colored blocks, I will use symbols, I will use as many different objects as I can to make it physically alive as well as mental concepts. And I'll move from physical structures to more abstract concepts. I think about cognitive processes that stimulate the development of the intellect. So I get students to think about doing things from different perspectives. So I might have De Bono's 6 thinking hats, and I get them to wear these different colored hats and to think, how do you approach this as a critical thinker wearing a black hat as opposed to a blue sky thinker wearing a blue hat who's organizing things? So they get an idea of the different perspectives. So the benefits of a scientific approach, be it in education and teaching, or be it in the subjects such as science, these improve our ability to understand. They give us language. So there are certain words that we've used, like hypothesis and hypothesis testing. And so there's general scientific language like that. And then within each of the sciences, like chemistry, we have carbon and hydrogen and oxygen. And if you've got an Apple Watch, it'll be telling you certain scientific things. And if you go to the doctor, he'll be telling you scientific things. And when you come home from the doctor afterwards, if you're taking notes, you can Google it and you can become an expert on your illnesses. You know, what did COVID mean? What happened? And all of this. So science is all around us, and it's important that we understand it. And as teachers, since we are involved in understanding students and education, we need to understand the science of education and the science of the human person. And since we're Christians, we need to also understand the Christian aspects as well. So some of the principles in learning activities, student-centered, we're looking at student self-concept. So we want to build students' confidence up. We're also looking at verbal learning. So students have got to learn new terms and words. So when we introduce them to chemistry or geology, there are certain words that have meanings. And then there's opportunity to learn laws and principles. And so we've got the law of gravity, and then there are laws of cleaning your hands, distance of 1.5 meters. And I've learned all sorts of laws with the COVID world around us. And then there's increased learning ability to think. And so we learn about thinking. We learn about what motivates us as teachers, what motivates students. And then we also develop skills as well. Now, in terms of self-concept and building one another up, there's a danger that some people may have a fear of science, Daniel, and the teacher will say, today we're going to do chemistry, and they'll bring out some test tubes and they'll draw CH4 up there on the blackboard, and we may not have a clue what CH4 stands for, and then they'll put up H2O2 or so. Yeah, they'll put these symbols up, and they expect us to know what it all means. Is there such a thing as fear of science, phobia science? How do we deal with that when some of our, us teachers have a phobia or fear of science and students have it, Daniel?
Yeah, you're spot on, Sam. I'll tell you what, I felt my anxiety go up as soon as you mentioned test tubes in a classroom and writing up CH4 on the blackboard. And so, I think we ourselves have talked about this, off screen in a previous week. But I think one of the ways in which we can take away a little bit of that anxiety is, first of all, we can see this immediately in some of the points below in terms of student-centered learning. You mentioned before that if we're just writing stuff, or if we're just telling people information, we're just spouting information at them, they're not using their own minds, they're not discovering for themselves. So I think, first of all, it has to be student-centered, and it has to be fun. I think students have to feel a sense of agency, a sense of experimentation and freedom about it, because I think one of the things that causes anxiety about the sciences is this idea that it is this incredibly rigid and rigorous subject in which there are all these laws and we have to know them and understand them, and you're either right or you're either wrong. And so similar, I think, a little bit to our earlier discussion on mathematics in that sense as well, and thinking about, I think we mentioned in the mathematics week, how many of us would have experienced a classroom where you immediately get called on, in a math class to say, what's the answer to number 17? And you're either right or you're wrong. And we talked about all the different levels of anxiety and pressure that would produce. And so I think we can conceptualize science teaching in that same regard, in terms of, okay, how do we minimize or eliminate the pressures that people have, whether it be pressures from being put on the spot in public, pressures from being in a peer environment, for example. So student-centered is first and foremost important. Make it fun, make it enjoyable, give students freedom. And I think as well, we started the lecture talking about how we used science today in terms of the cereal box or the petrol gauge on the car. I knew that I had to add milk to my coffee, even though I like adding milk to my coffee, because if I drank it straight away, I'd burn myself, right? So making it relatable as well. I think this really goes hand in hand a little bit with some of the things that we've talked about with maths as well. Not to put down the mathematically and scientifically inclined students here in EDU 121, because I think just as many of us may have had experiences like that in English or in history or geography or something else.
Yeah, so there's anxiety in a lot of subjects: art, music, physical education. And if we give students support and encourage them that we value them, surely that's a Christian approach. That's a loving, caring approach. Also, we need to recognize that there are times when knowledge goes beyond a simple scientific observation method. And we need to realize that there's a lot more going on in the classroom, a lot more going on in the world than very simple scientific methods that people often talk about. So recognize that, as Thomas Kuhn said, there are paradigm shifts that go much larger than these. We need to realize that there are two ways of looking at things, like the two mice that said, boy, have I got these guys conditioned. Every time I press the bar, they drop a piece of food. And so we humans think we understand what's going on in the animal world, but often there can be these other views as well. So there's lots that you can look at in seeking to understand the scientific world more fully. In particular, you need to be aware that science is one of the subjects in the Australian curriculum, and it includes methods that are used. And so you need to be aware of these. There are stereotypes of scientists who see them as not normal. And then there is the picture here of why science teachers shouldn't be given playground duty where they're banging them from one or another. So there are images of a science teacher wearing glasses, etc. Science, we know, is just about logically observing, measuring. It's something that we all do, because it's part of our culture, just as we all can do music, can do art, which are also part of our culture. But in particular, we need to be careful about pseudoscience, where one side or the other will claim we have the knowledge, when in fact they're not being humble, they're being vague, they're not talking about what's really there. So pseudoscience follows not where the evidence leads, but where the person wants to go. Pseudoscience isn't open to criticism, it's hostile to criticism. Pseudoscience uses vague jargon. Pseudoscience makes grandiose claims rather than conservative, tentative claims. Pseudoscience picks favourable evidence rather than looking at all of the evidence. Pseudoscience uses flawed methods rather than rigorous repeatable methods. So we want you in this subject to be aware of what is clear, sound thinking. And science is one example of natural environment subjects around us in which there's a rich tradition of using clear thinking, of which Christianity has contributed to that. As well as that, there are pseudosciences around, like astrology or whatever, which would be following very strange ideas. And so you need to be aware of reasons for these other pseudoscience beliefs. Sometimes it's political, sometimes it's community. There are other reasons why people follow pseudoscience as another way of thinking. So we need to realize that there are many good reasons for believing that our faith fits with science and Christianity. And so it's worth exploring further the ways in which Christianity and science work together. And so I encourage you to be aware that many people who've been great thinkers in the past have been Christians. In the book, The Soul of Science, Pearson and Thaxton point out that an awareness of sin makes us recognize the need to be careful about our thinking. That is, everyone can be ignorant, everyone can be proud. And Peter Harrison, in a scholarly article on original science and the problem of knowledge in early modern Europe, in the Journal of History Ideas, writes about how this understanding of the dangers of the fall of man led Christians who were scientific leaders of their time in the 1700s to warn that in all thinking, including scientific thinking, we need to be aware that the fallen nature of humanity and tendencies towards selfishness and pride can lead people to go astray. So rather than Christianity being at war with science, Christianity contributed to many important ideas of science. Robert Hooke, in The Development of the Microscope, says every man, because they've got corruption innate and born with, as the Bible describes as sin, they need to use resources such as the microscope and other resources, and that they also need to compare their ideas with those that the microscope and experiments tell them. Also, just as we have a description of rules and laws in Deuteronomy in the Bible, Christians who were scientists in the 1700s said there are going to be laws out there in the natural world. And you need to understand the law of gravity if you're an engineer, building engineering. You need to understand laws of medicine and chemistry if you're doing medicine and chemistry. René Descartes also was motivated by his Christian understanding of the universe to look for ways in which God orders and guides the world, and science is about seeking to understand the way God guides the world. So all through history, from Aristotle and Plato seeking to understand the world around us, from Roger Bacon through to Francis Bacon, Isaac Newton, Robert Boyle, the father of modern chemistry, said that God has created the world with laws which he has established. Daniel, as someone who has done study and thought, does study and thought take us away from faith and Christianity, or do things like science and study and thought fit in with a God who has created an ordered world, and encourage us to seek to understand God's ways and the sense of order in his world?
The short answer is both. So absolutely, we've already reflected on key figures like Bacon, for example, and how their faith can inform their scientific understanding, but also how their pursuit of knowledge, their pursuit of understanding the natural world, can really nourish their faith and grow their faith in terms of understanding how God works and how God operates. Now, on the other hand, I can tell you that personally, study, for me and for people I know, there can be occasions where you get so caught up in, you're doing a bit of research and you get so caught up in your own ideas and how smart you think you are, that you forget about the God who put you on this planet and the God who blessed you with the brain that he did. And so, I had a period, I remember when I was writing my doctorate, and I was talking to a colleague of mine who had a similar experience where I think you're obviously growing up so much in knowledge that there's you can have this little experience where you think, oh, I'm really great stuff and hot stuff because I've done all this study and I know all these wonderful facts and all these wonderful ideas. And the moment you think that, you correspondingly have a little bit less time for God in your life. And the reality is, as we've talked about, a lot of this, a lot of the scientific pursuit was born out of, especially, for those of you who in particular are familiar with, just after Bacon, the Renaissance about 200 years later, and the birth of humanism there, this idea that humans are flawed, we need God. Also, we need God, but also because we're flawed, we need to observe the natural world and understand it, because, we're not God. We don't know everything. And so I think in terms of, my experience, I think I really had to, and I'll be honest with you, some of those ideas I had weren't that great. I thought they were great. They weren't. And so I certainly had to, I think, reposition myself with God and get back to him. So it can go both ways, right? In terms of study and knowledge and seeking wisdom, it can bring you closer, but if you get caught up in your own knowledge and your own wisdom, it'll push you further away.
So drawing together the ideas for today, Daniel, we've covered the way in which science can be useful because it encourages us to observe, to experiment, to measure. But any claim to great scientific discoveries can also lead to pride and forgetting about there are bigger worlds out there that go way beyond what I think I know. And so if I've got a particular expertise about Piaget, and then I go and say in the staff room, having read, having known all of this, then I've got to be careful, because there's other people who may know way more than me, may have totally different views, so entirely different to me. I've got to be aware of them as well. Now, the study of history, I think, is very valuable because it reminds us that there are great thinkers through the years who've wrestled with these questions of science and faith and method and scholarship and teaching and how people learn. We can learn so much from them, and we can also learn from in our own lives, observing and thinking about people around us, the students in front of us. There's so much that we can learn. It's a wonderful learning journey that we're on. And in the weeks ahead, we're going to look further at these different subjects and methods that they have. And we're going to learn a great deal from them. I just thank you for the opportunity, Daniel, to dialogue again over one of the subjects, science, and the great benefits and ideas it has, but also the ways in which it fits with our faith and it fits with discovering who we are. And in assignment 2, you got to wrestle a bit with that. What are your major ideas about teaching, about the world? You can explore that much, much further. So thank you for the opportunity, Daniel, and look forward to catching up.
Awesome. That was terrific. I had a lot of fun.